Hi everyone. Today we're going to study about polynomial, the types of polynomial, terms, degree of a term, and degree of polynomial. First, let us define polynomial. Polynomial is an algebraic expression involving only the operations of addition, subtraction, multiplication, and raising to natural number powers on variables and constants. Example, 2x plus 5. Another example is x squared minus 4xy plus 2y squared. Third example, 9w. Fourth example, x cubed plus 3x squared minus 5x plus 2. There is a note here that in a polynomial, a variable cannot appear on three places. The first is in a denominator. So this is an example of not a polynomial, this x over 2x plus 1, because there is an x in the denominator. So this example here, 3x squared plus 1 all over 5 plus the fraction x plus 2 over 4 minus the constant 5. So this is a polynomial. It is true that there is a fraction, but in the denominator there is no variable. So this is a polynomial. So a variable cannot appear as an exponent. So this is another example. 10 raised to x plus 1. So in the exponent there is a variable x. So this is not a polynomial. So another case, a variable cannot appear within a radical, or we can say that as a radicand. So this example here, the square root of y minus 6. So there is a variable y in the radicand, or I can say that there is a variable inside the radical symbol. So this is not a polynomial. Here is an example of a polynomial. See here, the square root of 3 as a coefficient of x. See the radical, it is only for the number 3 and not the x. So there is no variable inside the radical symbol. Plus the fraction 5x over square root of 7. So in this term there is a fraction, but there is no variable in the denominator. So still this is a valid form of a polynomial. And then plus the whole number 1. This expression here is a polynomial. Let's go to term. As defined, each member of a polynomial is called term. I have here an example of a polynomial with three terms. So this is x squared minus 4xy plus 2y squared. So we may say that the first term is x squared, the second term is negative 4xy, and the third term is 2y squared. In a term, the number is called numerical coefficient, and the variable or variables is called literal coefficient. I will start with the third term. So in here, number 2 is the numerical coefficient, and the y squared is the literal coefficient. In the second term, the numerical coefficient is negative 4. The literal coefficient is xy. In the first term, the literal coefficient is x squared. There is no number here. For a term without any number, it is understood to have a numerical coefficient of 1 here. So the numerical coefficient is 1 for the first term. Let's go now to types of polynomial. The first is monomial. By the word mono, it means there is one term in that polynomial. Our example here is 2x. There is only one term. The second is binomial. By the word bi, it denotes two terms. Example is 5y plus z. Third type is trinomial. The word tri or the prefix tri denotes 3. Example is 3w squared plus 5w minus 1. For polynomial with 4 terms or more, we use the general term of it as this polynomial. So as an example, we have x cubed plus 3x squared minus 5x plus 2. Let's go now to degree of a term. As defined, degree of a term refers to the exponent of each variable. In case of multiple variables in a term, degree is the sum of all exponents of all the variables. Example, 3x raised to 5, the degree is 5, degree of 5, because the exponent of x here is 5. Another example, 2x y cubed, the degree is 4, because we have two variables here, so we are adding the exponents here, x with exponent 1, the y with exponent 3, so we add the 1 and the 3, so the degree is 4. Another example, p squared q raised to 5 r, degree of 8, we are adding all the powers, 2 plus 5 plus 1 equals 8. So the degree of this term is 8. Another example, 3y, obviously the degree is 1 because of this exponent here. A constant of negative 2, the degree is 0. As a rule, the degree of non-zero constant is 0. Now what about 0? There is no degree for the number 0. Let's go now to the degree of a polynomial. As defined, degree of a polynomial is the highest degree of the term in a polynomial. Let's have one example, 3w squared plus 5w minus 1. Let us identify the degree of each term. In the first term, the degree is 2. Second term, the degree is 1. The third term, the degree is 0. So the degree is 2 because the highest degree is 2, and that is in the first term. Let's have the second example, 10x cubed plus 3x squared y squared minus 5xy plus 2y cubed. Let us identify the degree of each term. In the first term, the degree is 3. In the second term, the degree is 4. Third term, degree is 2. Fourth term, the degree is 3. So the highest is in the second, and that is degree of 4. So the degree of this polynomial is 4. Third example, x raised to 7 plus x squared y squared minus xy plus y raised to 8. Let us identify the degree of each term. In the first term, degree is 7. Second term, the degree is 4. Third term, the degree is 2. The fourth term, degree is 8. So our highest is 8, which is in the fourth term. So it means the degree of this polynomial is 8. Hi everyone, today we're going to study addition of polynomials. First, let us define like terms. Like terms are terms with same literal coefficient, otherwise unlike terms. Let's have some examples here. I have here 4 terms: 2x, negative 5x, x, 3/7 of x. As I observed, the literal coefficients for all these 4 terms are x. So they have common literal coefficient. So these 4 terms here are like terms. Another example, I have 3 terms here. The first is 5a cubed b squared c. Second, negative a cubed b squared c. The third, the square root of 10 a cubed b squared c. Now, observing the literal coefficients of all these terms, it is common, and that is the a cubed b squared c. So we don't care about the numerical values or the numerical coefficient. Since they have the same literal coefficient, they are like terms. Third example, 10a cubed b squared. Second is 10a squared b cubed. In here, they have the same variables a and b. However, the exponents are different. In the first term, the power is 3. In the second term, the power of a is 2. While here, the b has an exponent of 2. In here, the exponent of b is 3. So they have different literal coefficient. So when we say the same literal coefficient, even the powers must be same. So in this example, for this group of terms, these are unlike terms. Fourth example, I have here 2 terms, 2a cubed b squared c. The second is 5a cubed b squared. So in the first term here, I have 3 variables a, b, c. In the second term, I have only 2 variables a and b. While it is true that the exponents for the a and b are same, but in the second term, the variable c is missing. So in this case, this is an example of unlike terms. Let's go now to addition of polynomials. Let's begin with addition of monomials that are like terms. The rule is given to add the numerical coefficients and copy the common literal coefficient. Let's see an example. 3xy plus 2xy plus xy. So we are sure that this group of terms are like. So we can add the numerical coefficients. I collected the 3, the 2, and the 1. The 1 is the coefficient of the xy. And then for the literal coefficient, we simply copy that same and common literal coefficient. So 3 plus 2 plus 1 gives us 6, and the xy, the literal coefficient, is simply affixed. Second example, 10xy square z cube plus 4xy square z cube. Again, looking at the literal coefficients, we are sure that these two are like terms. So we can now add the numerical coefficient. So the 10 plus 4, and then we copy that common literal coefficient, the xy square z cube. So the final answer is 14xy square z cube. Third example, 4xy square plus 2x square y. Looking at the literal coefficients, it seems there is a problem here. In here, xy are there, but the coefficients as compared with the second literal coefficients are not same. Here is x with exponent 1. Here there is an x with exponent 2. For the y, here is exponent 2. Here is with exponent 1. So we can see here that we can conclude that these two terms are dissimilar. And it says dissimilar terms cannot be combined. So when we are required to put the answer here, we simply copy that same problem. So our answer here is, I simply copied the 4xy square plus 2x square y. Let's go now to the addition of polynomials. The rule says combine like terms. Example 1. Simplify. There is a group of polynomial here, 6x squared plus 2x plus 3, plus the second group, 4x squared plus 5x minus 1. So the rule says let us combine like terms. So the 6x squared is combined to the 4x squared. We will get this 10x squared. Next is the 2x and another 5x on the other group. We can put them together. So we add the numerical coefficients. 2 plus 5 gives us 7. And we copy the x. And for the constants, here is 3. In the second group, there is negative 1. So 3 combined to the negative 1 will have the positive 2. So the final answer is 10x squared plus 7x plus 2. Let's see second example. Sometimes problem will come to you like this. Find the sum of the polynomial 2x squared minus 3x plus 5 and the polynomial 5x squared plus 4. We can rewrite this problem like this. Put a grouping symbol to the first group, list here, and then put a plus sign. Then take the second group, put a grouping symbol and place it next to the first group. And then we will go now to combining like terms. So here we have 2x squared. Here there is 5x squared. We can write the answer as 7x squared. And for the negative 3x, there is no term in the other group with the x as literal coefficient. So the negative 3x directly we can place in the sum. Make sure that you don't forget to include that negative 3x. And for the constants, the 5 plus 4 will give us 9. So the final answer is 7x squared minus 3x plus 9. Example 3. The three sides of a triangle is measured at 3x minus 2, x plus 1, and 2x plus 7. Find the perimeter of the triangle. First, we should know that perimeter is the sum of all sides. So we're going to add the sides of the triangle. So P, that stands for perimeter. So I collected the 3x minus 2, that is the first side, x plus 1, that is the second side, the 2x plus 7, that is the third side. And then we simply collect the like terms, the 3x, the x, and the 2x, we combine them together, we'll get the 6x, and the constants negative 2, the positive 1, the positive 7. We will get a positive 6, so 6x plus 6. This is our final answer. This is the perimeter of the triangle. Hi everyone. Today we will study subtraction of polynomials. First, let us review. Suppose there is an equation a minus b equals c. Naming the parts of these three numbers here, the first number representing a is called minuend. The second number b is called the subtrahend, and the result of this subtraction is called difference. Now let us go to subtraction of polynomials, starting with the first part, subtraction of monomials of like terms, meaning these are terms with the same literal coefficient. The rule is mentally change the sign of the subtrahend, then proceed to the rule of addition. To illustrate, suppose we have a minus b. What we will do, in here the b is positive, we will put the minus sign with a b, and then the operation becomes addition here. So it means to say, in relation with our rule here, in subtraction of monomials, suppose the b is positive, showing this as minus b means we should change the positive into negative. On the other hand, if your b is negative, we're going to change the negative into positive. And then we will use the rule of addition to combine the a and this b with a new sign, and we will get this variable c, or the difference of c. So let's have an example 1, 5x minus 3x. So for the 5x, that is the minuend, we simply copy that here, look at the 3x here. This is our subtrahend. So the 3x becomes negative 3x, and the minus sign becomes plus. And then we will apply the rule of addition. Since we have two terms here with opposite sign, we're going to subtract the coefficients, and then we will affix the sign of that coefficient with a greater absolute value. And then for the variable, we will copy the common variable or the common literal coefficient. So the answer is 2x. The positive 5 plus a negative 3 will give us positive 2, and the variable x is copied. So the final answer is 2x. Example 2. 5xy minus a negative 3xy. So we will change the sign of the subtrahend. From negative, it becomes positive, and the sign becomes addition. So the minuend is simply copied here. Then we will now combine the 5xy plus the 3xy. So we have the final answer as 8xy. Example 3. Negative 10y minus a negative 2xy. So again, the second term is our subtrahend, so we're going to change the sign. From negative, it becomes positive, and then the operation becomes addition. However, we can observe here that the first term and the second term are not like terms. Here, the literal coefficient is y, and on the second term, the literal coefficient is xy. So, as a rule, unlike terms cannot be combined. So for our final answer, we will simply copy all these terms. So negative 10y is here now, and then plus the 2xy. So final answer is negative 10y plus 2xy. Let's go now to subtraction of polynomials. The rule is we change the sign of all terms of the subtrahend, then add like terms. Let's see one example. Perform the operation. We have two polynomials here. 4x squared minus 2x minus 7 is our first polynomial, minus the second polynomial, x squared plus 5x minus 3. So the second group is our subtrahend. We're going to remove the grouping symbol for all these two groups. And then for the second group, we're going to change the sign. So the first three terms here are the terms of our first polynomial. Then the second polynomial, we will change the sign of all the terms. The x squared here is positive. In here it becomes negative. The 5x is positive. Here it becomes negative. The negative 3 becomes positive 3. And then we will combine like terms, or we will add like terms. We have here 4x squared. There is a negative x squared here, so we can combine these two. We have 3x squared, and then the negative 2x. There is a negative 5x here. We will combine these two. We will get the negative 7x, and for the constants, negative 7, and there is a positive 3. So it is negative 4. So our final answer is 3x squared minus 7x minus 4. Let's have another example. Subtract 5x squared plus x minus 4 from the 4x squared minus 6x plus 7. So there is a little analysis of the position of the polynomials here. We know that we are putting a minus b in a normal operation of subtraction. But based on the manner of the problem is written, the second polynomial here is considered to be the A, and this first polynomial here is our B. So it means to say we're going to put the second polynomial first, that will be our minuend, followed by our subtrahend. And then, as a rule, we're going to remove the grouping symbol, but we will change the sign of all the terms of the second polynomial. See here, the 4x squared minus 6x plus 7 are simply copied here without the grouping symbol. Then for the second polynomial, the 5x squared is positive here, it becomes negative. The plus x becomes negative x, the negative 4 becomes positive 4. And from here, we will combine similar terms. The 4x squared and the negative 5x squared, we can add together. We will get the negative x squared, negative 6x and negative x with both negatives. We will combine them. It becomes negative 7x. And for our constants, the 7 and the 4 becomes 11. So the final answer is negative x squared minus 7x plus 11. Let's have example 3. 2x cubed minus 5x plus 1 minus the quantity 3x squared minus 5x minus 6. So we will follow our rule. The second polynomial is our subtrahend. We will change the sign of all the terms of our subtrahend. So 2x cubed is here, minus 5x plus 1. And then the 3x squared becomes negative 3x squared. The negative 5x becomes positive 5x. The negative 6 becomes positive 6. And then we will collect and combine like terms. The highest power here is the cube. So it seems there is no other variable with cube. So only this one, the 2x cubed. We will simply copy this. And for the followed by this negative 3x squared, there's no other term with a variable x squared. So we will put this negative 3x squared in the final answer also. For the negative 5x, and there is a positive 5x here, it is cancelled. Then for the constants, it is 1 plus 6. It becomes 7. So our final answer is 2x cubed minus 3x squared plus 7. Hi everyone, today we will study multiplication of polynomials. Let's begin with multiplication of monomials. The rule is multiply the numerical coefficients and multiply the literal coefficients or the variables following the laws of exponent. Let's see the first example, 4x cubed times 3x raised to 5. We understand this dot here denotes multiplication. So we're going to multiply these two terms. So the rule says we're going to multiply the numbers. So that is 4 times 3, we will get 12. and the x cubed multiplied to the x raised to 5. We will add exponents, so we have x raised to 8. So the final answer here is 12x raised to 8. Second example, 2x raised to 4y cubed times the negative 5x squared y. So the parenthesis here denotes multiplication. So we will multiply the numbers, the 2 times the negative 5, we will get negative 10. The x raised to 4 multiplied to the x squared, we will get the x raised to 6. The y cubed multiplied to y, so there is a exponent 1, so 3 plus the 1 equals the exponent 4, so y raised to 4. Our final answer is negative 10 x raised to 6 y raised to 4. Example 3. Sometimes problem will come like this. Find the product of negative 3x squared y cubed z raised to 4 and the term negative 2x raised to 4z. Let us rewrite the problem into this form. So using the parenthesis symbol to denote multiplication. So let's begin the multiplication. Let's start with the numbers. The negative 3 multiplied to the negative 2 will get a positive 6. The x squared multiplied to the x raised to 4, we will get this x raised to 6. The y cubed, there is no variable y on the other term. We will just copy the y cubed. The z raised to 4 multiplied to the z with exponent 1. So we add the exponents, so 4 plus 1 becomes 5. Z raised to 5. So our final answer is 6x raised to 6 y cubed z raised to 5. Example 4, when we multiply negative 5a by the term 2b. In here we can see that there is no common variable. So what we'll do, first we will multiply the numbers. Negative 5 multiplied by 2, we will get the negative 10, and the variables a and b, we'll just put them together in the final answer. So our final answer here is negative 10 ab. Example 5, the terms are 2/3 x cubed 5/7 x squared. So we multiply the numbers. In this case, we have fractions. So the numerator multiplied to numerator, denominator multiplied to denominator. So we have the 2 times 5 becomes 10, 3 times 7 is 21. For the x cubed times x squared, we will get the x raised to 5. So the final answer, 10/21, x raised to 5. Let's go now to multiplication of monomial and polynomial. Rule says multiply the monomial to all terms of the polynomial. Let's have example 1. The 3x is multiplied to the polynomial x squared plus 2x minus 10. So what we'll do, this 3x, we will multiply to each term of the trinomial here. Let's begin with the 3x multiplied to x squared. We will get this 3x cubed. Then 3x multiplied by 2x, we will get the 6x squared. The third, 3x multiplied by negative 10, we will get this negative 30x. So our final answer, 3x cubed plus 6x squared minus 30x. Example 2, the polynomial and the monomial can be interchanged in position. So in here we have the polynomial x squared y cubed plus 2x plus 3y times the monomial 5 xy. So the same procedure, each term of this polynomial will be multiplied to the monomial. Let's start with the x squared y cubed times 5xy. We will get the 5x cubed y raised to 4. As we see here, the x squared with the x with exponent 1 will get x cubed. With the y cubed multiplied to the y with power 1, we'll have the y raised to 4. Next is the 2x multiplied to the 5xy. The numbers becomes 10. 2 times 5 is 10. For the x and x becomes x squared. The y, there is no y in the term here, so we'll just copy the y in the product. So 10x squared y. The next is the 3y multiplied to the 5xy. We'll get 15. There is no x on the first term here, so we have the x, we simply copy, and then the y times y, we'll get the y squared. So our final answer, 5x cubed y raised to 4 plus 10x squared y plus 15x y squared. Let's go now to multiplication of polynomials. The rule says multiply each term of the first factor polynomial, that is the multiplicand, to each term of the second factor polynomial, that is the multiplier. Then we add like terms, if any. Example 1, 3x plus 5 multiplied by 2x minus 1. So what we'll do, the first term 3x of the first group will be multiplied to the terms of the other group. So the 3x is multiplied to 2x, we'll get the 6x squared. 3x multiplied by negative 1, we'll get the negative 3x. The next is the 5, the second term of the first group, we will multiply to all terms of the second group. So 5 times 2x, you will get the 10x, and 5 times negative 1, we will get the negative 5. And then we will see if there is a like terms. As we see here, the negative 3x and the 10x are like terms, so we can add them. So the negative 3x plus 10x becomes positive 7x, and then the final answer is this 6x squared plus 7x minus 5. Example 2, 2x plus 1 multiplied by the x squared plus 3x plus 4. So what we'll do, the 2x, the first term of the first group, we will multiply to all the terms of the other group. So the 2x multiplied to x squared, we will get the 2x cubed. 2x times 3x, you'll get the 6x squared. 2x times 4, you'll get the plus 8x or positive 8x. The next is this one here, we will multiply also to all the terms of the other group. So 1 times x squared, we will get the x squared. 1 times the positive 3x, here is positive 3x, and 1 times the positive 4, we will get here plus 4. And then we will observe for some like terms. As we see here, the 6x squared and the x squared are like terms. Also, the 8x and the 3x are all like terms. So we can combine those like terms. So the 6x squared and the x squared, both positive, becomes 7x squared. The 8x and the 3x, also both positive, is equal to 11x. So we just bring down the 2x cubed, we bring down the constant 4, So the final answer here is 2x cubed plus 7x squared plus 11x plus 4. Let's go to example 3. A plus b multiplied to the c plus d. So the a is multiplied to the terms of the second group. A times c will give ac, then a times d will get the ad. Next is the b multiplied to the terms of the other group. So b times c is bc, then b times d is bd. So our final answer is this AC plus AD plus BC plus BD.